this week delivered one of the most unexpected plot twists in global spaceflight. China pushed its reusable rocket ambitions closer to reality. SpaceX turned a dramatic test failure into momentum. Russia discovered serious damage at its main launch site, and the United States nearly confirmed a new NASA administrator who could reshape exploration priorities. In this video, we break down what happened, how these results were obtained, and why they may influence the next era of space activity. China's recent orbital achievement marks a turning point for its commercial space sector because it shows how quickly private companies are transitioning from traditional expendable launchers to reusable systems that rival global leaders. The Zhuke-3 rocket, developed by Landspace, not only reached orbit successfully, but also attempted a controlled first-stage return, a maneuver that requires precise engine throttling, aerodynamic balancing, and onboard guidance capable of adjusting in real time. This attempt matters because it demonstrates China's intent to build rockets that can reduce cost per launch and accelerate its long-term exploration strategy. Reports from this week confirm that the rocket achieved its orbital target, but during the descent attempt, the booster experienced an abnormal combustion event. Engineers explained that the landing burn did not stabilize as expected, causing the booster to lose its recovery profile. While the booster was not retrieved, the mission still delivered a valuable outcome: a full dataset from its first landing attempt, including engine performance curves, grid fin control behavior, and heat shielding response during descent. These measurements feed into simulations that help refine the landing sequence, just as early Falcon 9 flights created the knowledge SpaceX later used to perfect rapid reuse. The significance goes beyond one flight. China is currently supporting an ecosystem of private launch companies, including Landspace, iSpace, Galactic Energy, and Deep Blue Aerospace, all developing reusable methane-oxygen engines. Having multiple companies competing towards similar goals creates innovation pressure, and Zhuke-3's near success shows that competition is delivering tangible progress. The rocket's structural design, including composite materials and modular engine clusters, was built with reuse in mind rather than being adapted after the fact. What makes this moment especially meaningful is its timing. As global launch rates continue rising, the ability to reuse boosters becomes central to managing cost, schedule flexibility, and environmental impact. Even without recovering its first stage, Zhuke-3 proved it can reach orbit efficiently, and that its designers are ready to gather imperfect results, analyze them, and attempt again. This approach signals a clear shift in China's role in the global marketplace, no longer catching up, but actively joining the frontier of reusable launch development. With more test flights planned, Zhuke-3 stands as one of the most closely watched rockets in the world, and this week's attempt suggests its future milestones may arrive sooner than many expected. This rapid recovery reflects SpaceX's build and iterate philosophy, where each booster represents an incremental evolution rather than a single long-term asset. Booster 18's failure was not treated as a setback, but as an expected part of refining a design intended for frequent reuse. The event also highlights optimized thrust structures for the 33 Raptor engines. A failure under test conditions reveals whether those upgrades behave as predicted. In this case, engineers gained data about tank resilience under non-nominal pressure conditions, which informs reinforcement strategies for later prototypes. The knowledge contribution is significant because the V3 model is intended to support rapid launch cadence, long-duration missions, and potential future refueling scenarios in orbit. What makes this moment important globally is its timing relative to other nations' progress. SpaceX Booster 19's rapid assembly demonstrates that SpaceX's infrastructure is built for continuity, not dependency on individual hardware. This mindset keeps the development cycle moving forward while improving reliability with each iteration. As Starship moves toward higher altitude flights and more aggressive reusability goals, the insights gained from Booster May 18th become the foundation for the program's next major milestones. While China and SpaceX were advancing hardware, Russia encountered a major launch site complication that raised questions about its near-term flight readiness. After a Soyuz rocket lifted off from the Baikonur Cosmodrome, Post-flight inspections revealed that part of the launch platform had failed during liftoff. Reports describe a large structural section near the flame trench collapsing inward, leaving significant damage that must be addressed before the site can support future missions. Engineers confirmed the issue was mechanical and not related to the rocket's performance, but the repair process will take time, affecting scheduling flexibility. The Baikonur Cosmodrome is historically important. For decades, it has served as Russia's primary gateway to space, especially for crewed missions. With one of its major pads now offline, planners must reassess upcoming launch windows and potentially shift operations to backup locations. This introduces logistical complexity because alternative pads require configuration changes and fresh certification before they can support human-rated missions. The damage underscores how essential infrastructure resilience is in the global space landscape, particularly when launch systems rely heavily on a single operational site. China pushed forward with a major orbital milestone. SpaceX transformed a test failure into progress. Russia faces essential repair work at a historic launch site, and the United States edges closer to selecting its next NASA leader. Each update reflects a different part of the same story. Global space activity is accelerating, reshaping expectations, and opening new paths for exploration. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Thank you for watching, and see you next time.